After looking in probability, conditional probability, uh, now we'll be seeing in binomial distributions. So basically, binomial distributions are categorized into discrete and continuous. So again, random variables play a vital role in probability distributions, and also serves as a base for probability distributions. So probability distribution is a statistical function which links or a list of all the possible outcomes a random variable can take in a random process. So which is correspondence probability of the occurrence. So here on the right we can see uh, that random variable is divided into probability distribution in discrete manner and also in continuous manner. So this is what we had already seen with respect to the example, right? So distribute when we were checking with respect to the subblock of the data, so it was divided into discrete data and continuous data. So those are the types of data which will be dealing with respect to this probability distribution. So discrete probability and also continuous so discrete and continuous probability distribution. So for an example, probability distribution for a discrete random number. So let us consider the number of heads. So like tossing a coin, we'll have a scenario where we'll be tossing a coin three times. So over here, like there can be like it can go like all the three times as 0 or all the three times as 1. So basically, there can go up to 0, 1, 2. Okay, so three particular times. So 0, 1, 3. Okay, so number of heads can be 0, number of heads can be 1, number of heads can be 2. So basically, this is tossing the number of times as 2. Okay, so then the discrete random variable and their probability distribution will be called as discrete probability distribution mass function, or sorry, the discrete if a random variable can be taken only a finite set of values, so discrete random variable then will be called as the probability distribution as probability mass function, so PMF. So let me just rephrase that. So the discrete random variable and their probability distribution for such type will be called as uh, probability mass function, so PMF, and the probability distribution of a dispute and a variable in a list of values of different outcomes and their respective probabilities can be given in the list of above over here, where we can see like 0, 1, 2. So we have 0 times as 0.25, 1 time as 0.5, and the probability of getting the third head is 0.25. So the continuous probability distribution of a continuous random variable will be called as probability density function. Okay, so basically for uh, discrete it will be mass function, probability mass function, and for continuous it will be density function. Okay, continuous density function. So we'll be like we'll see what is the need of probability distribution. So according to the definition of a random variable, it is the variable which can hold different set of values from the outcomes of random process. However, it lacks the capability of capturing the probability of getting those different values. Okay, so those individual values. And also the probability distribution helps to create a clear picture of all the possible sets with their respective probability also of occurrence uh, in a random process. Okay, in any random process. So that is why we need a random distribution process. So again, here we can take many examples, use cases where we will be taking like many decision will be taking in business, insurance, and other real life situations by assigning the probability of getting the possible outcomes. So based on that only we will be taking decisions. So we always tend to go towards a positive outcome rather than a negative outcome. So for a positive outcome we will be checking out with respect to probabilities. So that is the reason why we need positive probability distributions. So like again here saleswoman can compute probability that she will make like 0, 1, 2, 3 or 3 or more sales in a single day. Then she would be able to compute the average number of sales she can do per week, and then if she's working on a commission, so she will be able to have calculate appropriately how many weekly income she will be getting over time, or whatever it is, like based on the probability. This again making the sale will be on different factors which we won't get into it. And also it can be like same for an investor who wants to risk two different stocks on his portfolio. So there are two stocks, he's not sure which stock he should go with. So obviously everyone wants to get a positive outcome. So when he wants to see which of the stock has higher probability distribution when it comes to growing like booking profits rather than going in loss or something like that. So based on that criteria, so that is why it is necessary. So now we'll see a few of the standard probability distribution. So there are many, we'll be concentrating only on the three. So first is binomial distribution. So binomial distribution uh, can be simply thought as a probability of a success or a failure outcomes in an experiment uh, on target. Okay, so that is like if we didn't want to prevent now, so then based on a survey that can repeat multiple times. So the binomial distribution is a type of distribution which has only two possible outcomes. So again, binomial data type will be used over here. So basically that will be a boolean. So now you can see an example over here. So a coin can be tossed. So this is the only two possible outcomes are heads or tails. So this will be coming under a binomial distribution. So taking the test could be getting only two possible outcomes, pass or fail. So it is directly the name is self-explanatory, binomial. Okay, so the same like the data type which we discussed earlier. So again, what is the criteria for the binomial distribution to meet? Okay, so there are a few criteria. So the number of observations or trials should be finite, which means that they should be comfortable. They should be countable. Okay, they should not be intended to infinite. So I just want to measure the probability of heads when I toss the coin infinite number of times. So that doesn't make any sense. We can't find probability like that. So probably if you tell the probability of getting heads when the number of times I get an head when I toss the coins 10 number of times. So that is a fixed number of observations or fixed number of trials what we will be doing. Okay, so that is the first condition. And now for each condition or a trial is independent. Okay, so it should be independent. It should not be dependent on each other. So in other words, none of the trials has an effect of the probability of the next trial. Okay, so probably you are working on a data set where you have maybe you are throwing 5 rocks, out of which like randomly one rock is taken out of a box. Okay, so on the next trial, you if you don't put back the rock taken out and going for the next rock, so obviously probability will be varying. Okay, so that's why here you won't be getting that cannot be considered as binomial distribution. Again, if you have only two possible outcomes, definitely you cannot have more than two outcomes. And if you're keeping the other rock out aside, then the next trial cannot be performed. So that's the reason for each trial should be independent of the other trials. And the last criteria is the probability of success. So basically here it can be tails or heads or fail or pass. So I can consider whether heads, if you are choosing heads, the probability of getting heads would be your probability of pass. So it is the exact the same for one trial to another. Okay, so it will be like the success rate should be same for individual trials also. So that is the three criteria for binomial distribution. So here again we have a small formula of binomial distribution. So again we won't be deriving any of these. So here where you just check out with respect to formula, it is n divided by x, p of x into q of n minus x. So here it is nothing but number of trials. X is the number of success desired. So basically for a heads or tails, you desire it should be heads. So that will be x will be success, and p is the probability of getting success. And what about q? Q would be nothing but 1 minus p, so that is the failure. So that is represented in terms of q. So this is how it has been calculated. Okay, so if you expand the formula also, you can get on the right hand side as like something in factorial divided by n minus x factorial into x factorial, p power x, q power n minus x. So again, if you are learning about probability in mathematics, you will be having derivation how exactly this formula has come up. So we won't be going that into it. So overall idea we have got what exactly is binomial distribution, and this is the formula. And next we have Poisson. So Poisson distribution over here is nothing but Poisson distribution is the probability is a probability distribution that is used to show how many times the event is likely to occur over the specific period of time. Okay, so that is Poisson distribution. So the solution is that how many times it like event will be occur. So in other words, it is down to the distribution. If I have time to put it in the way in such a way that uh, we will be getting the distribution oftenly used with respect to the favorable events. So in other words, it is a count distribution. Again, you will have countings. So Poisson distribution are often used to understand independent events that occur at a constant rate within a given interval of time. Okay. So maybe you have 10 seconds to toss the coin. You can toss on an average. You can find out how many times you can toss and what is the probability of getting all those as positive this one. Okay. So again, the formula is given something like this. So over here, p of x will be equal to lambda to the power of x square, x and e to the power of exponential to the power of minus lambda divided by x factorial, where lambda is nothing but a mean of the successes over the given interval. Okay, so you will be having the data set. So you will find the mean of the success. Okay, not the mean of the outcomes, rather mean of the success. And again, lambda can be found as variance of x. So again, it is named after a French mathematician. So here we have an exercise, an example. If the average number of people who buys cheeseburger from a fast food chain on a Friday night at a restaurant at a location is somewhere at 200. Okay, some location. So if the average number of people visit over there is 200, so a Poisson distribution can answer whether what is the probability of more than 300 people will buy the burger. So basically you'll find 200 people as the average number. So on a random day it might be more also or less. So what is the probability that 300 people will end up over there? So Poisson distribution can answer such kind of questions. So that is the advantage of Poisson distribution. And next we have normal distribution. Okay, so this is the last one which we'll be discussing. So this is also known as Gaussian distribution, so most commonly known as Gaussian distribution or normal distribution. It is a probability distribution that is schematic about its mean. Okay, so we had already seen such kind of data set with respect to a graphical representation. So basically showing the data near to the mean are more frequent in occurrence than the data far from the mean. Okay, so this is like in graph form. Again, I had already discussed about bell curve. So that is what here it will be happening. So basically here the two standard normal distribution, two parameters would be the mean and the standard deviation. Okay, so mean is nothing but the average value which should have the highest number of frequency, and deviation is nothing but the other places where it is like I mean the other outputs which are like deviated from the mean. Okay, so same particular graph. So same particular graph over here we have just given with respect to the probability on the left hand side. Okay, so same thing. Okay, next more about normal distribution. For a normal distribution, 68% of the observations are like within the plus minus. So it's like in the standard deviation itself. So one standard deviation, and 95% are like within 95% are within plus or minus to the 2 standard deviation, and 99.7 are within 3 standard deviations. Okay, so even if you consider the previous graph over here, so you can see first standard deviation, second standard deviation, and third standard deviation. So you can see that is what is represented over here, and many things come closely to follow normal distributions. For example, heights of people. Okay, so usually people who are too short will be very less in number, and also people who are too tall are also less in number, whereas average height is coming in the between. And similarly, size of machines, size of things produced by machines. Okay, and error of measurements, definitely blood pressures, and also marks on test can be also considered like that. So this marks on test will be for individual student. Okay, so with respect to his or her different ways, and this is the formula which will be getting. So the Gaussian formula is nothing but 1 divided by variance of root 2e, which is equal to exponential to the power of minus half
x minus mu. So here it is again like variance divided by variance the whole square. Okay, so mu is nothing but our this one. So sorry, I mean with respect to our mean. So again, the variance and the mu over here is like a bell curve with a different centers and spreads accord depending on the mu and variance values. Okay, and also the constants pi and e. So pi is nothing but 3.14 and e is exponential is nothing but 2.1, 2.71. If you are familiar with, if you are a bit with mathematics, so you can like probability, all probability distributions, you will be familiar with these constants, pi and all. I think everyone knows, and exponential if you have worked on it, logarithms and all, then you will be familiar. Else just remember the value. Okay, that would be more than sufficient. So again, we have a process known as standardizing score. So using normal distribution, so the number of standard deviation from the mean is also called as standard score. So basically, this is what we do standardization, and standardization helps a lot when it comes to machine learning, creating the algorithms. So basically, over here you have a normal distribution which is varying like the mean is at around 110, sorry 1010, and the deviation is from 990, 970, like in terms of 20. And after standardization, you will be having 0 as your mean and -1, -2, -3 as your deviation, standard deviations. Okay, so first standard deviation, second, so plus or minus, okay, on the both sides. Hence it is symmetry. So by doing this standardization, you won't like, one thing is you can have easy comparison between different features. Okay, so you will not be just comparing one or two features of a data set. So if you do standardization, you can easily compare based on their weightage. And also with respect to the number of calculations will be reduced down in your machine learning when you write projects in Python. So that is about normal distribution. Few more about normal curves. So basically, the more congested the data is in the middle of the distribution, the more data falls within the interval. Okay, so previously we had seen like the first interval, second interval, third interval will have 99.7%. So the lesser the data falls within the interval, the more dispersed the data is. Okay, so again, this would be the representation of it. So standard deviation being 0, straight line 0.5. So you can see the curve is like mostly like congested within the interval itself, and my standard deviation being 1, standard deviation being 2. So you can see the graph is kind of moving further and further. So here standard deviation values will be more. Okay, so that's all about probability distributions.